Want to discuss about the channel creation process. Okay, even though many of them remember or have conceptualized the channel creation or also the VTH, the threshold voltage, as the minimum voltage at which the channel is created, right? So this is the definition: minimum voltage at which there is a channel. But if we go a little deep into the physics and try to analyze a little bit more about the channel creation, intuitively it will be very easy to solve many problems. For example, a mere definition of minimum voltage that is required to create the channel is very plain and does not give many physical insight of the MOSFET. So today I would like to explain few points considering the channel creation or considering the VTH, and we will design accurately what is the minimum voltage VTH and how the channel is actually created. And I'm assuming that whatever I draw now you already know. For example, I'm just drawing a N type MOSFET. So this is a N diffusion, let's call it source, and this is this is a drain, this is the gate, this is polysilicon, this is SiO2. Okay, now the channel is actually created. Actually I have to draw it like this, something like this. Okay, so this area, that is this area, is the area under SiO2 where the channel will be created. So now let's just want to cut this part and draw it here. So if you look at that part, there is a polysilicon, correct? There is a SiO2 and there is substrate, that is P substrate, correct? And here is the voltage which you apply, and this is our substrate, and usually the substrate is connected to the source. This is your gate voltage. So let me apply a voltage here VG with respect to the bulk. So this is like a ground. So when I say VGS, it is with respect to ground or the substrate. Okay, so this is the potential applied between the gate and source. So the first step when you apply voltage is there is electrical field which is created in a direction from positive supply, that is from this point to this point. So what happens is, this is an insulator, nothing happens here because there are no charge carriers, but all these positive charges will sit here at the end, and they have to, every positive charge has to terminate on a negative charge. Okay, so an electrical field will create a flux where every positive uh, where positive flux lines will terminate on the negative terminal. Okay, so the first step what is happens is, because there is electrical field and this is a P substrate that is having more holes, P holes are in majority but N, that is electrons, are in minority. So the first point which you must know and understand is the number of holes into the number of electrons is always a constant called as Ni square. So if the hole concentration increases, it means N0 will come down, so that the product is always Ni square. So for a P substrate, if I have to draw, let me draw this diagram like this. This is my gate polysilicon, this is my SiO2, okay, this is my P substrate. Okay, so here I have applied a positive charge, so there is electrical field. So when there is electrical field, because it is positive, it will attract electrons, right? So below this diagram here, I want to I will draw the diagram in terms of charge carriers. Okay, so because this is P substrate, let's say P0 is the holes and N0 is number of electrons. Because it is P0 will be more, it means N0 will be less. So let me draw the whole concentration here. So this line let it be equal to P0, and this green line let it be equal to N0. Okay, so P0 is greater, N0 is less in this material. Okay, so initially what happens is when you apply a voltage between gate and source, okay, the electrons that is minority charge carriers will increase. It means P0 will decrease. Why that happens? Because of the positive charge, it will attract, or it want to attract electrons. It needs um, to get a electron. It will try to attract the electron. So the minority charge carriers just below this SiO2, the electron, let me try to show. Let's say there is electron here, there is a strong field from this from here to here. Okay, so this electron will move here and it will combine with the hole, so it will create negative charges, it become depleted. So I will try to show this in this diagram. Here the electrons will come and combine with the holes and will create ions. Okay, now every positive charge here will terminate at a negative charge. Okay, it will happen like this. Now when this is happening, the depletion region will be created, negative charges. Let's say there is depletion region up to this. So at this point, that is, let's say this is up to this point, there is depletion region which is created. So what will happen now is I will use still here in this substrate, from all this part the P0 concentration is as it is, but here the number of holes have reduced. Why? Because they are combined with electrons and created ions, and when you reach this point it is completely less. So the concentration of P0 will start to bend like this, it will start to bend. So if P0 is reducing, N0 has to increase. Why? Because of this formula. So they will increase like this. Okay, now what will happen, this is at some VG voltage, that is VGS voltage. Now if I increase the VG voltage further, the electrons will from here will come here, but it has no holes to combine, because all the holes are already combined, they have created ions here. So this electron which has come now here cannot combine, and it is free for conduction. So that happens when the gate voltage is such that this band bending, I will use white color, this band bending is such that P0 will becoming N0 and N0 will becoming P0. So this white color line is a point where VGS is equal to VTH. Okay, so what has happened at VTH? The P0 has gone so low that it has become equal to N0, and N0 has come up such that it has become equal to the initial P0. At this point, any electron which is coming from the substrate to this region, it has no place to combine with the holes, so it becomes a free electron. So at this point we say that the channel is going to start getting inverted, or this is the voltage at which the channel is created, because only at this voltage the electrons which come in this area are free to conduct. Before this, all the electrons which came from this place and landed here, they created ions. They were not free for conduction. Only after VTH voltage the electrons became free to conduct. So this is how you must remember.